How does light diffraction work? Imagine shining a flashlight through a tiny opening and seeing the light spread out in a pattern rather than just going straight through. That's what diffraction is all about. It happens when light waves encounter an obstacle or pass through a narrow slit. Instead of traveling in a straight line, the waves bend around the edges and spread out. This bending occurs because each point on a wavefront acts like a tiny source of new waves, called wavelets, which radiate in all directions. When these wavelets overlap, they create interference patterns, which look like bright and dark bands or fringes. This process is explained by the Huygens, Fresnel principle. It says every point on a wavefront is a source of spherical wavelets. These wavelets combine to form a new wavefront, which is why the light appears to bend or spread out. The effect is most noticeable when the size of the obstacle or slit is similar to the wavelength of the light. Visible light has wavelengths around hundreds of nanometers, so diffraction becomes clear when light passes through tiny slits or around fine edges. When light passes through to closely spaced slits, the diffracted waves overlap and interfere, creating a pattern of bright and dark lines. This pattern is called an interference pattern and shows how light behaves like a wave. It's why shadows have fuzzy edges instead of sharp outlines. The amount of bending depends on the wavelength. Longer wavelengths bend more than shorter ones. Diffraction isn't just for light. It happens with all kinds of waves, including sound waves, water waves, and even particles at the quantum level. For example, when you see the rainbow colors on a CD or DVD, it's because light is diffracting off tiny grooves. The same thing happens with water droplets in clouds, creating the shimmering silver lining. Scientific instruments like diffraction gratings use this principle to split light into its different colors for analysis. Understanding diffraction helps us see how light behaves in many everyday situations. It shows that light isn't just a straight beam but a wave that can bend, spread, and create beautiful patterns. This wave behavior is fundamental to many technologies and natural phenomena we observe all around us.